working with steel shafts. You'll see much more consistency in steel than you will in the vast majority of composite shafts. Also, the raw frequencies of two different shafts, say like the Apollo Aculite 75 and 85, with the same raw length and marked as R-flex, may not start out with the same raw frequency. Oftentimes, a lighter shaft will naturally have a lower CPM as there's less material or wall thickness. And this is what helps to make each shaft pattern different from one another. Again, as a club maker, you're only concerned with sorting and possibly sub-sorting the like shafts that you have at hand. Okay. Now, let's take a look at graphite shafts. I probably should say, instead of graphite, as they're often called, they're composite shafts. That is, they're manufactured with more than one material, like steel. Each composite shaft may be made up of several continuous strands wetted with epoxy and wrapped around a forming mandrel, or maybe possibly made from 30 individual sheets or flags of pre-preg material wrapped around the forming mandrel. Each batch of raw material may vary slightly in weight or the modulus or the stiffness of the shaft, plus each shaft has several finishing steps that steel shafts aren't subjected to. For instance, a composite shaft will be sanded smooth. If not careful, too much sanding will affect the stiffness of the shaft. Also, composite shafts are painted. Some lighter colored shafts may be painted up to 3 times to avoid the black or the charcoal base color of the shaft from bleeding through to the exterior color. This extra step is one way of adding a little bit of weight tolerance, but it won't affect the flex of the shaft. And that's the reason why weight sorting alone is not the best method to sort composite shafts. Now, the best method is by using a frequency analyzer with the drill chuck or the tip weight, as mentioned before. Weight sorting is better than no sorting whatsoever, but it's no guarantee that you're going to be sorting the shafts correctly. You could use a deflection board, but you have to be very careful not to crack the ultralight shafts, as that's a very good possibility. And some club makers have made other devices to place the shaft into in lieu of a frequency analyzer. They may have some sort of a gauge to measure the force when the shaft's deflected. Also be very careful, as the raw lengths of composite shafts are not always exactly the same raw length like they are on a raw uncut steel shaft. You may have to make adjustments by clamping different in your frequency analyzer, or even taking the time to cut the butt ends so that all the raw shafts are of the same length. Okay, our next slide, okay. Again, you don't want to be a nibbler by cutting arbitrary amounts to hit a target frequency number. Again, if the shafts don't match raw, they won't match cut. Use the tolerances to your advantage. You don't want the distance from, say, the bottom of the silk screen to the ferrule to be inconsistent, as it's going to raise a red flag to your customer. Plus, by trimming arbitrary amounts from the tip over and beyond what the manufacturer suggests, you're going to affect other parameters, such as the torque of the shaft, the tip stiffness, and eventually the feel of the golf club. There is a rhyme and reason why the manufacturers suggest the trimming methods at which they do. Now let's go back to what we said about the change in frequency among steel shafts. This also applies to composite shafts, but maybe not to the certainty as you would see in steel. But we'll use these values as good approximations. Shafts cut in half-inch increments, like 1.5 inches for the 5-iron, 2 inches for the 6-iron, or an inch difference between a 3 and a 5 wood. Remember, there could be a 4 wood. this will change the frequency at a rate of 4 to 5 CPMs per half inch. This is not very common in graphite shafts because of their reduced parallel tip lengths as compared to steel. More commonly in graphite, you're going to see shafts trimmed in quarter-inch increments. So you'll only see like a 2 to 3 CPM change per half inch in length. And lastly, graphite shafts, which are all butt cut, these will not increase in stiffness or frequency number at all, but they'll have the same frequency or CPM throughout the set, and we call this the flat line frequency slope. And while that may work for some golfers, I'm not a big fan of the flat line frequency slope. The reason is the club becomes shorter, you're looking for more control, not necessarily more height, distance, or feel. And this is where I start to use the tolerances to my advantage. I sort the graphite shafts by frequency ahead of time, then start by putting the most flexible shaft in the longest iron or wood, the next most flexible shaft in the next longest, and so forth until I put the stiffest shaft in my shortest iron or wood. This way, if I butt trim only according to the directions, I will get some sort of a slope frequency with the longest club being the most flexible. This just might help the ball get airborne. And then the short clubs will be stiffer and provide some additional control. Even by cutting the shafts in quarter-inch increments, which normally would have 2 to 3 CPM intervals between clubs, you might get a frequency slope closer to that of steel, like 4 to 5. Now that's using the tolerances to your advantage. Now you're ready to cut your shafts or bundle them together in light groups, so the next time that you need to make a set of clubs with those shafts, they're already pre-sorted. Well, that's a wrap. Let's send it back over to Rob and we can field your questions.
All right, guys, let the questions start coming. It's a very well-attended webinar today. First question's from Rick. Does the weight attachment matter? Should it be a specific weight, for example, 250 grams?
What I would say is if you use a weight, it really doesn't matter what the weight is as long as it's heavy enough. Just be sure that you're consistent in using that same weight and you put it the same depth. A lot of times, like on a drill chuck, the shaft tip would stop at a given point. It can't go any further. Just make sure it goes all the way in, or if you're using the ones with the thumb screws, make sure you go to the edge. But it really doesn't matter what you use as long as you're consistent with it. Good question, though.
Okay, next question is from Mr. Liu. So if I don't do CPM, I will put lightest weight shaft to longest club.
Correct. Now, again, we demonstrated even in the steel shafts, it's not exact all the time, but if you're going to put anything in a logical sequence, that is the best method. It's better than doing nothing at all.